Graphing equations, Chapter 3, specifically equations of a straight line. There are three forms of the equation of a straight line. There's the standard form. It's ax plus by equals c, where a, b, and c are integers. There's the slope-intercept form with the slope m and y-intercept at 0, b. It's in the form y equals mx plus b. Recall that m, the slope, is mathematically defined as the rise over the run, which means the difference between the y-coordinates divided by the difference between the x-coordinates. There's the point-slope form. Given a point x1, y1 with a slope m, you'll have the equation y minus y1 equals m times the quantity x minus x1. Just a little note, a variation of the standard form is the general form, where you have ax plus by plus c equals 0. A, b, and c are an integer form, with a usually in front of the coefficient of x being a positive integer. This is problem 49 on page 251. You have an equation x plus y equals 3. This is standard form. You want to subtract x from both sides so that the x's on the left will be canceled and you'll be left with y by itself on the left-hand side, and your new right-hand side will be negative x plus 3. This is now in slope-intercept form. To match it up, you know that y equals mx plus b means that m, here the coefficient in front of the x, is negative 1. So your slope is equal to negative 1. b is 3, which means that the y-intercept has the coordinates 0, 3. This is problem 51 on page 251. You're given y equals 1 over 2 times x plus 1, and this is now in slope-intercept form. You know that the y-intercept is 0, 1. It's the b part of the y equals mx plus b. That is the point 0, 1. We have a slope of 1 over 2, the coefficient in front of the x, which means we go up 1 and over 2. We have a straight line. We can also graph using points. If we substitute negative 2, 2, and 4 to the x value, our y-coordinates will be correspondingly 0, 2, and 3. This is the point negative 2, 0. We already have 2, 2, and now this is 4, 3. This is problem 55 on page 251. A straight line equation requires a minimum of 2 points, x1, y1, and x2, y2. If x1, y1 is equal to 0, negative 5, and x2, y2 is equal to 1, 0, then the slope is the difference of the y over the x's, giving you 0 minus negative 5 is 5, divided by 1 minus 0 is 1. Now we have x1, y1 is equal to 0, negative 5 is the y-intercept, and x2, y2 is equal to 1, 0 is the x-intercept. The slope-intercept form only needs the y-intercept. Therefore, our final equation in slope-intercept form is y equals 5x minus 5. We just substitute our m, which is 5, and the b is negative 5. This is problem 59 on page 251. You're given a line that has a slope of -3/2 and asked to find the perpendicular line that passes through the point 3, 0. The slope of any perpendicular line will have an opposite sign and a value that is the reciprocal of the original slope. Or in this case, since the original is -3/2, our perpendicular slope of a line will be +2/3. The point slope form will be, substituting where the y is with the x is, you'll get y minus 0 is equal to 2/3 times the quantity x minus 3. When you distribute 2/3 to the quantity x minus 3, you will have on the left-hand side y equals 0, 2/3 times x minus 2, which is now in slope-intercept form.